Okay, so we're going to go ahead and do the last type of test that you're going to need to know for Chapter 9 on convergence and divergence. There is another section. There's a few more sections of Chapter 9. How much? I don't think we're going to, just due to the semester that we find ourselves in, we're not going to get through. We're not going to go through all of Chapter 9 like I would like to. But this is the last test that we need to be able to master. And now, we're only going to do one problem, and the reasoning for that is it's very similar to the ratio test. So, what was the plan for this section? So I'm gonna go over this test really quickly, do an example, and then I'm gonna give you a summary of all this next little page that I'm gonna produce is something you could remember. You can go to my website, get the handout for this section, and print that page because it's a summary of all the tests, right? So without further ado, let me go ahead and tell you what's going to happen here. So remember, you always have an a sub n, right? That's what you're given in the series. And all this root test says, it says, well, let's just take the nth root of that, right? So we're gonna just take the, not a square root or cube root, it's the nth root of your a sub n. And then we'll come back and we'll talk about when it converges, diverges, or is inconclusive. As you can see, it's very similar to the ratio test. And in fact, it's very hard to figure out should you use a ratio test or a root test, at least in the beginning, and sometimes you just try both. So in this case, I'm going to erase this. In this case, I would not fault you if you started here with trying to use a ratio test. In fact, if you can finish it using a ratio test, do it. If you can't, if it's either very messy, very complicated, then let's try the root test. So let's identify that a sub n, in this case, is e to the power of 2n over n to the power of n. Now, what we're going to do, what we're going to do is we're going to take the nth root of that, right? So let me show you what I mean. So we are going to take the nth root. Now, we normally have an absolute value symbol there because you can't take if you want to stay in the real number system, we can't take the nth root, or when the index is even at least, of negative radicands. So, but we're just going to take the nth root of e to the 2n over n to the power of n. Right? So let me show you why I think you'll like this test. Because if you recall, let me see if I can write this off as an aside really quickly. So first off, you should know that if you have let's say the square root of, 4 over x, you can rewrite that as the square root of 4 over the square root of x. That's the first thing to keep in mind. The second thing to keep in mind is if you have the square root of, let's say the square root of x to the power of 4, you can rewrite that as x to the power of 4 over 2, right? So do you see, really quickly, please follow me, do you see how the index, that 2, ends up dividing into that 4, like this? Now, we're going to use both of these. Let's do them piece by piece. Ready? So, first thing is let's go ahead and write the nth root of e to the 2n over the nth root of n to the power of n. Then let's go ahead and, just like you can take your index inside your, and you're going to divide that by that exponent. We're going to do the same thing here. So this is going to be e to the power of 2n. Notice the radical disappeared because you're now going to divide by n. Okay, again, go up here and look at this right here if that is confusing you. Over, well, this is going to be n to the power of n, and now the radical disappeared, so that's going to be divided by n. Okay, so in this case, we end up with e squared over n to the power of 1. Now, that was actually easier than the ratio test, I think you would agree. So let's just go ahead and take the limit of that, as with n moving to infinity, of e squared over n. Well, that's simple enough. That's just equal to 0. Well, what does that mean? That means 0, since 0 is less than 1, we get to say that the series converges by root test. Okay, so again, not bad, right? Very similar in its approach to very similar into the ratio test. Let me now move to the last part, which you can screenshot this if this is helpful, or you can again, you can always go to my website and find this handout. It's right, it's from 9.6, and this just gives you some ideas, if it's a geometric series, if it's telescoping series, p-series, alternating, root ratio, direct comparison, limit comparison. This is just a quick guide for some of the various tests that you've learned. And, well, let me be honest with you that the only thing left to do is for you to practice, because you have all the theory. You are just going to be of the type that thinks that you're either going to be of the type that thinks that just because you've watched me do a few different problems, you're ready, until you get to a test and a problem pops up that you haven't encountered, or at least a form of that you haven't encountered. And it would be really nice to make all your mistakes when it doesn't. There's no penalty, right? That's what the homework is for. So you do what's best for you. I can only just suggest what I think. Okay, I will see you sometime. I guess in the next video. Take care.